Good morning guys, I hope we are well. In today's lesson we're going to be continuing solving problems by using Pythagoras' theorem. Okay, so today we're going to start by talking about zip wires. Right? There is a point to this, we are going to be doing some maths to do with zip wires. Right? So by zip wires I mean these things that we often see in play parks, so where you sit in the seat and it zips you down from point A to B. But today we're going to be looking at much bigger zip wires, so ones sort of like this. So the kind of zip wires that Boris Johnson likes, clearly. And I myself have also been known to enjoy a good zip every now and then. Alright, so let me introduce the problem. Let's say an adventure company wants to build a zip wire where you start from the top of a tower and you travel to a point on the ground. So they're going to build a very big zip wire. I'm going to give you some information about this problem. Let's say the tower is 60 meters tall. And let's say the finish point on the ground is 80 meters from the foot of the building. What I would like you to do, I want you to pause the video at this point and think, what question do you think I'm about to ask you? Okay, so the question I'm going to ask you is, how long should the zip wire be? The way we're going to solve this problem, we are going to draw a sketch. So let's consider the information that we've been given. First of all, it tells us that the tower is 60 meters tall. So my tower, I don't need to draw anything fancy, I'm just going to draw a line. So my tower is 60 meters tall, so I'm drawing a line which represents my tower, and that's 60 meters tall. Okay, so the next bit of information we were told is that the finish point on the ground is 80 meters from the foot of the building. So I'm going to add to my sketch the finish point. So let's just draw a little cross, and this is the finish point. So the finish point is 80 meters from the foot of the building. So the foot means the bottom. So this distance from the cross to the bottom of this tower represents 80 meters. So I'm just going to connect that up with a line and label it with 80 meters. So now our task is to figure out, well, how long should the zip wire be? So if we're thinking about where we would be stood at the top of this tower, and we would be zipping all the way down here to the finish point. So the question really is, what is the length of this dotted line? Hopefully you're starting to picture Pythagoras' theorem. This problem makes a perfect right angled triangle, so let's use Pythagoras' theorem. We know that the longest side, so the hypotenuse side, we label C, and then A and B are the other sides, and it doesn't matter which way round I put A and B. Okay, so Pythagoras' theorem we know is a squared plus b squared equals c squared. Substituting in a and b, that tells you 60 squared plus 80 squared equals c squared. Okay, at this point, let's do some maths. 60 squared, well 6 times 6 is 36, so 60 squared would be 3600, and so on. Okay, so let's do some more maths. Let's add these two values together. That tells me that c squared is equal to 10,000. So thinking back to the last few lessons now, how do I get from c squared to just c on its own? Well, at this point I would take the square root of both sides of my equation, and that tells me that c equals 100. So in other words, the length of that zip wire would be exactly 100 meters, and I have solved the problem. 100 meters is my answer. Okay, so next problem. I'm going to tell you that the Bottisham Sports Hall measures 70 meters by 30 meters. So that's the lengths of the sides of the hall. What I'd like you to do, just like in the last problem, please could you pause the video and have a think, what question do you think I'm about to ask you? Okay, the question I'm going to ask you is, what is the distance from one corner of the hall to the opposite diagonal corner? Okay, so at this point, again, I would like you to pause the video and see if you could use Pythagoras' theorem to work this out. To use Pythagoras' theorem to work this out, what I would like you to do, you're going to make a sketch of the information that I've given you. And as soon as you're ready for the solution, please just unpause the video. Okay, let's start by making a sketch. Let's draw the Bottisham Sports Hall. So here we go. It looks kind of like a basketball court, doesn't it? Alright, so We know that it measures 70 meters by 30 meters. So I've just added those lengths to the sports hall. And what I mean by the distance from one corner to the other is this length here. So either this length here, or you could have chose the opposite corner. It doesn't matter, you'll get the same answer. So basically we want to find this missing length. And hopefully by now you can just see that this is a Pythagoras Theorem problem, just dressed up in this context. So really it's just a right angle triangle, and we're finding that missing length, the hypotenuse. So let's go ahead and use Pythagoras' theorem. Which side am I labelling C? Well, C is always the longest hypotenuse length opposite the right angle, and then A and B doesn't matter which way around I label them. So let's use the theorem. Let's substitute in A and B. Let's work out 30 squared and 70 squared. Let's add these two values together. Okay, and now remember at this point, C squared, well, how do I get from C squared to just C on its own? What I will do, I will take the square root of both sides. So that tells me that C, I've used my calculator for this one because it's not a square number. So this one is about 76.2 meters, and I've rounded to one decimal place, so round sensibly. So that tells me that my hypotenuse length is 76.2 meters, and that seems a reasonable answer given that this length was 70 meters. So I've solved the problem. Okay, so in this lesson I'm going to give you a choice, because I think some people will be quite confident with this skill and other people might be finding this a bit tricky. If those two examples made sense to you, if you're happy with what I just said, you're going to try option 1 on your worksheet. So option 1 is word problems. For each of these word problems, you need to read the sentence, you're going to draw a sketch and look out for some right angled triangles you could use to apply Pythagoras' theorem. So your other choice is, if you're not feeling that confident and if you just want to practice the basics, you're going to try option 2. Okay, so that's using Pythagoras' theorem to find that missing length for each question. So on your worksheet, you will find all your solutions. Alright, so as always, please just send me an email or contact me on Google Classroom if you would like any help. Thank you very much.